noticing that. That's a good catch. Thank you. Yeah, as soon as Ankita is able to share, we will get started.
Sure, Kishore. We'll wait for some time as few more participants are joining. They're taking some time.
Okay, sure. Yeah, yeah.
So in the meantime, you will be ready with your presentation with the team.
Yeah. Ankita, I was able to see the screen share, but then again, maybe disappeared.
Okay, you're not able to see it now?
Now I'm able to see it. Yeah, now I'm able to see it.
Okay.
Yeah, so here, just let us know when you want us to start.
Yes, you can start, Kishore.
Okay. So I guess first I want to make sure in the meantime, the folks on our team who is planning to share your code, just be ready with your maybe GitHub, etc. So first I wanted to this week we focused on our initial what the goal was. We wanted to show all the components at least even with the basic stuff implemented and integrated. So that was our initial goal we set internally. I think for the majority of the part, we were able to do that, but there are some challenges that we need to work through. So yeah, switch to the agenda slide, Ankita. So we'll focus on first next two slides. We'll focus on the sentiment analysis, pattern identification, correlation analysis on our data sets, and what our team is implemented there, and what our insights are. So we're going to briefly talk about those, and then we'll talk about our overall architecture, a quick walkthrough, and then the overall solution demo. Again, it's not yet fully working, but at least we want to show the code that the team has implemented. We will be able to quickly walk through at least the high level aspects of the code and the components and their interaction. And then currently, what are the current challenges that we would be focusing on this week, and also the focus areas for this week. Okay, so with that, for you, yeah. So I guess is it Ankita? Yeah, can you take over, Ankita, on these next couple slides? Ankita and Victoria and Liz.
I believe Victoria, she's well, yeah.
Can you please show next slide? Yeah. So our team has completed the correlation analysis on the data we have. We had data about different kinds of cyberbullying. Also, we had information on gender, age, and some other parameters for our data set. And there is a high positive correlation between depression levels and anxiety levels, stress levels. So it means that there is a lot of people who face many problems simultaneously, not only depression. There is also a positive correlation of depression levels and gender, which in terms of that data set means that there were more depressed females than males. And among the types of cyberbullying, the highest correlation was with unwanted social contacts on social media. Means that among, say, for example, malice and other types of cyberbullying, the highest level we found was with unwanted social contacts. And then we also found that there is a negative correlation of depression levels, age, and education level. So there is some connection between time spent online and also activity on social media, but the highest correlation we found is on with one type of cyberbullying and depression. Thank you for your attention. Let's start with other analysis our teams conducted. Thank you.
So Ankita, are you planning to share the GitHub code? Or is it Liz will be sharing?
Yeah, if Liz would be talking through it. I don't know
Yeah.
if Liz is in.
Yeah.
Okay. Do you want to bring up the GitHub code? Okay. Okay.
I
Perfect.
hope
Thank
you
you.
can see it.
Yeah. I'm able to see it now.
Yeah, perfect. Thank you, Ankita, and good morning, good afternoon, good evening, everyone. We took you through the pattern identification, I'll say, model that we came up with. As you can remember from our last presentation, we did have data around conversational data. So we got a couple of data sets that had a couple of questions and answers from users and answered by therapists. And so we use a particular data to carry out a bit of semantic searches, sentence similarity. So we searched from the beginning, Ankita.
Yeah.
Just scroll all the way up. So I used sentence transformers from Hugging Face to run this model. You just go all the way down, just continue scrolling. Ankita. Thank you. So I was able to use, I got the data sets from what we collected, just go all the way, and I use the transformers to ideally build a sentence similarity model. Go all the way down. Let's continue on. So we're able to combine all the data sets, and the final output of this were groups. So these were groupings of related questions. And what the objective was to get to a point where we're using this model to input, to take a user's comment or question that gets into the chatbot, and we look for related, use the sentence transformers to look for related questions and answers. So the question, and we get the answer from the question, which we'll use as context to give to the LLM. And what we're trying to do with that is just to make it efficient to get data, one, from a database, but also to try and ground the LLM using validated data from what we'd collected. So this is one part of analysis, and I'll ask Pranav to take us through the next one.
Actually, I want to make one comment here to the broader team here in here. And so I think our initial intention was to use this pattern identification to, based on the user situation, see which pattern or cluster group does he fall under, or which closest question that user is experiencing. And then accordingly, what's the answers that therapist has answered. So we were planning to use that data, but then we were thinking, is this maybe maybe instead of going this approach, why can't we just directly ingest all our CSV data that we have, whether it's whether counselor chats or therapist, patient data, right? So ingest all of the conversation data sets directly into vector database along with our recommendations data. So that way we could do semantic search directly in the vector database and bring the relevant question and the answers, as opposed to doing this pattern identification and passing that context to the LLM. So I think we are taking a slightly different route. So in the sense, instead of using this output from this model, we're planning to ingest a vector database, the CSV conversational data, CSV data directly into vector database and see how that would behave, how that would perform. Okay, so wanted to give some context on that. So with that, I think the next one is the sentiment analysis model. I think Pranav is on the phone. I don't think he can. I don't know if Pranav or Debanjan, can you?
Yeah.
So okay, perfect. Okay. Yeah, go ahead, please.
Share my screen. You guys able to see the screen?
Yes.
Yeah. So for sentiment analysis, we use the text classification data without features. So where the columns are the text and the label. So label is 0 or 1, where 1 is representing the non-depressed and 0 is representing the depressed. Okay. So we used Distilbird for sequence classification model to train this thing. And I think we trained for around 20 to 30 box with learning rate, I think close to 0. I think, 0.002. Okay. And we haven't used any kind of other optimizer kind of thing. Sorry, default optimizer we used at Adam. Okay. So yeah, so after training, I think we are getting close to 90% in each precision recall and F1. So I think I can say it's a great model. Okay, so we used that in categorizer part. So I'll explain the diagram later. But for sentiment analysis, the input will be our summarized text and output will be whether the person is depressed or not depressed. So this is the function we wrote. Okay. And we are loading the model and tokenizer with the help of auto tokenizer and auto model for sequence classification. Yeah, that's for sequence classification.
Yeah. Thank you, Debanjan. Again, thank you, Debanjan. So again, as you guys are seeing, as you folks are seeing here, the input is the summarized text, which when we get to the architecture diagram, you will understand where that summarized text is coming from. And the expectation of this one, it will basically output whether it's a depressed or not. So our thought process is when we're responding back our final summary, we will also include this as part of the output to the user, whether it's his situation is being classified as a depressed or not depressed situation. Okay. So with that, Ankita, if we can flip it back to the presentation. Again, sorry, folks. Again, we've been doing a lot of context switching and screen sharing. So trying to give you a real code walkthrough as opposed to be a screenshots. So yeah, Debanjan, go ahead and you can walk us through the architecture.
Sure. So this is our updated architecture from last week. So the main components here are the front end, the orchestrator, the rack pipeline, and the analyzer part. So so now I'll explain the flows. Okay, there are two flows. Okay, from first, the user will input his details, the demographic details in form. You can see in the front end there are two things: form and chat interface. Okay, so he will input his details in form, then submit, and then he or she will start chatting with the chat. So before starting this query response chat, I think you can see the user response is giving in form. It's directly going to categorizer. Okay. Okay. Now the query response thing. Okay. So user will start chatting with the chatbot with chat interface. You can see the query response flows are there. Okay. Yeah. So then from the chat interface, the query will come to conversation chain. From this conversation chain, the query will go to the retriever. From the retriever and the vector database, will get our finer context from there. And then it will flow to again orchestrator and then to our fine-tuned decoder model. So before that, we are thinking to add also the guardrail model, but it's still in progress, the thought process. Whatever, I think, yeah. So now the fine-tuned decoder model will get the response and it will, get the query and context and it will generate the response. And with orchestrator, we will flow the response back to front end and user can see the response in chat interface. Yeah, so till now is there. Okay, so I think after a few times of conversation, the question answer pairs, we will end the flow with the help of our recommender agent. Not there, but it's all an idea. So agent then gives the conversation thread to the summarizer, and the summarizer will summary with the help of an LLM model. Then it gives the summarized conversation to the categorizer, and categorizer will take the help of our sentiment analysis and pattern recognition, and also the summarized conversation, and give the recommendation to the user. That's the simple. Can I go to the demo, Krishna? Or I think you are in mute.
Yeah, go ahead, Devanjan. You can go to the code walkthrough, the solution code walkthrough.
Oh, yeah. Let me share.
Yeah, we're still trying to have our UI and integration fully make it fully work. It's pretty in the initial stages, I would say. So Devanjan will walk us through the code and overall code, the rack pipeline code that we implemented. And hopefully next week we can have a fully working demo.
Are you able to see the screen?
Yes.
Yes, yes, Deepanjan.
Okay. So this is the refactored code and our demo IPMP. Okay. So yeah, this is the orchestrator where we are connecting everything, front end, then rack pipeline, and the analyzer as well. Okay. So one by one, I'll explain. Starting from the rack pipeline. In Retriever, we implemented a parent-child retriever. Okay. And before that, starting with the loader, we implemented the 5 PDF. We're taking the depression guide .web PDF. So right now we have only one PDF, and the idea is also to integrate multiple PDFs at once. Okay. That is our PDF loader part, document loader part. Then we are using the recursive splitter, and this is the parent document retriever. So in advanced RAG, we implemented this thing because for native RAG, we are not getting great retrieve context. That's why we choose this thing. Okay. Then generator, we are using the Llama 270 chat fine-tuned model. So chat fine-tuned models are generally better for chatting than the instruct one or the base one. We haven't still fine-tuned the model yet. That's why we preferred this chat tune model in GGUF format, because we are using the CPU for here. Okay. Max token, these are the parameters you can see. Max token, the temperature, repetition penalty, context length. Okay, so this is our rack pipeline. Then back to orchestrator, the conversation chain, what I'm talking about. So this is implemented here. Okay, conversation retrieval chain, where we integrated the LLM, the retriever, the memory, as well as the prompts as well. Okay. Now let me show you the prompts. Yeah. So here we gave a little bit touch of mental health therapist kind of thing. Okay, so it's very much fine-tuned. You can see that you are a mental health specialist. Your job is to provide support for individuals. Things here. So LLM can understand what he needs to do. So these are the prompts. Also, using chat history, you also need the follow-up prompt as well. So we also have the condensed question prompt, help to understand better previous chat conversation. Okay, so yeah, the front end will connect to this orchestrator, and we're using this thing, this function, LLM generator function, okay, to implement flow. Okay. So next, after this this flow ended, we need the AI and human conversation to generate the summary. Okay, that's the next thing. I think that is in our here demo. So you can see after this demo ended, we'll have this kind of thing. A human and working overtime, and I'm depressed kind of thing. And AI will give you some kind of solution here. They're sorry to hear that. You're feeling down about this. It's totally normal. Feel frustrated when we encounter challenges in life, but remember you're not alone. Okay. With this kind of guidance we're getting from AI. Okay, it's a little big. Okay. But, so this is our orchestrator pipeline. After this, we'll summarize this thing, the whole thing. Okay. Then I imported the summary and printed this thing. We can see the summary of the whole conversation. Human is frustrated because he can't solve the problem of constant buffer. We'll meet with the professional therapist at option 2. Okay, he will be able to share as much as little as he feels comfortable with her. So this is the summary part. In diagram, you can see also from after summarizer, we'll also have the categorizer. We haven't implemented that yet, but the idea is given this thing, this summary, okay, the categorizer will categorize it in 2 classes, whether it's whether human is depressed or not depressed. Okay, that thing. And also from pattern identification or the classification model will get a few other details, okay, that able to see the screen. Hello.
Yeah, we can.
Yes. We thought these classes will show the user to recommendation. Either this classes or this classes integrated with LLM in more natural language fashion. Okay, is depressed, the severity of the depression, top features that is affected the user. Okay, any other topics for discussion, and what's the LLM's recommendation. Okay. So after recommendation, our flow is text. This is our code and this is the diagram, and I want to share the screenshot, the UI. So you can see a question and the answer from UI. So after following a question, we are getting some errors. That's why we have to show UI in the demo. We are working on it. So these are the things. The challenges right now we are facing, and we can say, I think, conversation chain, we're not getting good response back from our generator. Okay. Then the problem we're facing and categorizer as well. We have to implement the ML model. I think we have very few data. That's why we're not able to identify topics from there because it's not distinguishable. That are our challenges. And next step, we'll try to implement, or we will try to modify everything, and it will work as a good. It will work as a fine app. Okay, and the UI also will fix. Yeah, that's all I can need from our side.
Okay.
I'll quickly share maybe before Ankita you take
Yes.
over. I just want to share. This is so the team. I don't know if I'm able to do a screen share. Can you guys see?
Yes, yes, Kishore.
Yes.
Okay. Sorry, I reinstall. Are you able to see this? See the Streamlit UI?
Yes, Kishore.
Okay, so this is what the team is trying to implement, but we are, as Devanjan said, we are having some challenges in the responses back. For example, when I said, I'm feeling tired and want to sleep all day, it said, of course, I'm here to listen and offer support. It's completely normal to feel down or unhappy from time to time. Talking about feelings can be a great way to process them. So I think we're trying to have a consistent response. I think it's kind of unpredictable at this point. So that's where our focus would be on trying to make our conversational agent more kind of a consistent as to the possible extent, and also sometimes the responses are not the ones that we were expecting. So that's where we're going to focus on that this week. Okay.
Sure.
So with that, I think
Sure.
with that I would yeah, go ahead. Okay, sorry.
Yeah, sure. Thank you, Kishore. I guess you have completed the presentation.
No, I think we still have a few more slides here. So Ankita, can you go ahead and resume our slides, please? Let me see if I can stop the presentation.
Yeah, I think Sayak can go ahead with his fine tuning. Sayak?
Yeah,
Yeah,
I don't know.
give me a second. I will
Yeah,
share.
go
Yeah.
ahead. Yeah, go ahead, Sai. So we're going to talk about the fine tuning and alignment, the DPO. So again, Sayak going to quickly talk about where he is currently at and what's the focus for this week.
Okay.
Yeah, just give me a second. Just tell me if it's visible. Um,
Yes, we're able to see the code.
yeah. Okay. So first of all, we weren't able to go too much into depth this week because I'm currently out of station. But what we were able to do is set up a baseline model for the fine tuning. Um, so currently we decided to use this therapist human couple data set for the fine tuning. And the model that I'm currently using is an instruct model for Mistral 7B. We did have a conversation about this. I had a conversation about this with Kishore, and I will change the model. The only reason I use this is something I've worked with before. Um, but currently, I did not run too much evaluation yet. But as you can see, the basic structure remains the same. Like it's basically first we have the prompts coming in, then we make it into a standard format as usual, padding and everything, and then there's this generate response function. Um, um, which basically takes these encoded stuff and then decodes and then replaces. Um, and finally, you have this LoRa thing for the low-rank approximation. Um, and this kind of has some. We also need to do some tuning in the hyperparameters. Like I said, this is a baseline, um, and of course, and then you run the trainer SFFT trainer. Um, yeah, so this is what I've pushed currently, but I'm hoping to improve on this within the next couple of days, and yeah, hopefully we will have a better idea. DPO has not yet been implemented into this, but that will be done within the next couple of days. So next week hopefully we can show you a much better evaluation of how fine tuning is working from my end.
Yeah, so we'll be focusing on trying to come up with what our alignment database data set would look like, SFT data set would look like, and running through SFT trainer, DPO trainer to improve our LLM responses. And back to you, Ankita, if you can just bring one last slide, I think we can quickly wrap it up and we can conclude. So if you can bring those slides back, Ankita. So as the team is saying, because the current challenges are, because we're using some local LLMs, right? Um, uh, the running on CPU is really kind of painful. Every change, every test, it takes huge amount of time. So we're trying to see what infrastructure we could use. I mean, any feedback, any suggestions, and any of GPU availability would be helpful for improved response and testing cycles. And We will see if we want to use Rasa and Streamlit because there are some challenges. So I don't know if we maybe may drop completely Rasa and then maybe we do some advanced prompt engineering to make sure that the user experience, user questions are stay within the bounds, stay within the framework. The other challenges, I think team challenge was, for example, team tried to look into the Llama index. But again, since so in the last few months, there have been so many updates to the frameworks and the libraries. I think it's kind of putting a little bit more challenge to get up to speed and implement. And the next week again, currently we couldn't ingest vector embedding of CSV files, so that would be focused for this week. We're doing ingesting CSV files into vector database and also trying to see if we can use Llama index and LangChain to see if that would improve our framework. And so moving into the next slide, Ankita. So the focus areas for this week, I would say ingesting CSV into VectorDB and advanced RAG and user experience. I think this is where we wanted to see if we can implement multiple agents, like chat agent and recommendation agent is two separate agents. Maybe they can talk to each other for better user experience. And fine-tuning DPO that we just talked about it. And I know Victoria started looking into LLM guardrail, so she'll continue to further understand, see how we can integrate from ethical consideration, ethical and safety, responsible AI consideration standpoint, and then testing and validation, and also the deployment tuning. So that would be focus areas for this week. See how much we can accomplish. I know this would be a lot of stretch for the team, but we'll try our best. And this is the acknowledgements again. Team has everybody tried to pitch in. There are multiple people worked on rack pipeline, and we integrated the code. So these are the folks again. Want to thank you for all your efforts for this week. Okay, with that, back to you here. Can't hear you here. Maybe you might be on mute.
You're muted.
Yes, thank you, Kishore. That's a great presentation from your team. So we can just for time being, we can take one question for the team 5. So anyone has question for Kishore and team? If not, we can directly jump to the team 4. Okay. Okay, then so team 4, you can start your presentation.
Hey, Aya, how are you?
Yeah, I'm fine, good.
Okay, Tracy, Tracy is here?
Yes, I'm here,
Tracy
Aksa.
Can you please share your screen?
Want me to share the presentation? Sure.
Yeah.
Yep. Oh, hang on one sec. Hang on. Sorry, I was having computer issues before. Hang on one second. Okay. Okay, can you, everybody
Yeah,
I'm gonna go back to the beginning. Okay, go. Okay, and we can see that?
Yeah.
Okay.
Okay, thank you so much, Tracy. Okay. Okay, this is the presentation from team 4. This is our team. We have a co-lead and leads here from each team. Okay, go ahead, Tracy. Okay, today's topics is our mainly focus on the team progress that what we are done so far, and secondly we will show that what's the response from our model that we get that we actually wanted to achieve. So yeah, these are the topics that we will cover in this presentation. Project topic, as you know, that we will provide the interactive assistant to address the social issues like addiction, as isolation, cyberbullying within the age group of 14 to 25. So yeah, this is our project topic. Move ahead. Okay, team goals were individual. Like for the team collection, data team collection is to gather and provide the high quality data to the model building team. Sorry, to the data processing team. This data was actually based on the model that we actually will use. It was like the prompt. First, we need to provide the prompt, and then we need to show the answer that the answer is accepted or rejected. Those basis on the basis of those format. Data collection team needs to provide that on all three issues, like addiction, cyberbullying, isolation. Data processing team was task was to do some analysis and perform some scripting to in order to help the data collection team to gather the data most as much as they can. Okay, move ahead. Okay, then we have model building team goal. That model building team will require to perform the model like based on the DPO training, and before that they need to provide the demo related to the some like Microsoft 5 to Mixtral and Mental Llama models. So they will provide the details of that afterwards. And we are actually working on the Streamlit ads. That Streamlit app we are actually creating to provide the user interface in order to understand that how will our response will look at the query of the user. Okay, Tracy, now you can continue
Okay.
from here.
Yep, thank you. Thank you, Aksa. Data processing, I'll cover 2 slides on our data collection process. And a big thanks to Amelia, who's the co-lead on this effort, and all the team members that contributed. So our goal was really in line with what the model building team advised, and we have a unique and progressive approach. So our approach is really direct preference optimization, which is a different approach, I think, than the other teams are taking. So what we needed to do was provide pairwise preference data. And so our target is to collect at least 2,000 pairwise preference roles. And I'll show you an example in a moment. Across the subject areas that we talked about, cyberbullying and social media isolation, social media addiction and social isolation. And how we did that is we used prompt engineering, and we used Gemini and GPT, and we provided guidance for the prompts in requesting a specific outputs format, as well as input of what kind of data sets that we wanted the ChatGPT or Gemini to leverage, the large language model to leverage. So they provided different, everybody in the team provided different sets of questions and different data for these to use. And we got a number of different spreadsheets back, and the data pre-processing team helped out in this effort. One example of the 2,000 rows, and we still have more, data to collect, is, hang on one second, oops. Hang on, there we go. For one example, from a social media addiction perspective, is this question. I'm 16, addicted to Instagram and YouTube Shorts, especially during the holidays, but I'm trying to focus on studying. And in these preference pairs for training the model, we would have to give them advice on the chosen solution versus the rejected solution. So the chosen solution for training the model would be something like, it's commendable you're aware of this addiction, trying to stop, set specific goals for your study session, allocate dedicated time, and so on. The unchosen or rejected response would be something like, just rely on your willpower. You can manage both studying and excessive social media use, and don't even worry about it, which would not be the guidance that we would want the app to provide. So that's the approach we took. And now I'm going to switch over to the data pre-processing team, and I think Narayan is going to present.
Priyanka will present. Priyanka is here.
Oh yeah, Priyanka, thank you. Priyanka, do you want me to just keep the slides up? Okay.
Okay,
Yeah.
go ahead, Priyanka.
Yeah, team. Yeah, we are part of the data, as a part of data processing team. So we are generating the synthetic data so as to augment the real time data. So for generating the synthetic data, we are using a prompt engineering technique wherein we are giving the instructions to the large language model to generate the responses. And for the model building team, as we are using the DPO approach, so we need the data in a specific format, like we need the prompt as well as the response J, which is the correct explanation of the prompt, and the rejected responses, that is like incorrect ones, like which is not good. So we have written a Python script which is which will automate the process of generating the responses J and K.
You mean
And
to go
then
to the next
as
slide?
part,
Okay.
no, just a minute. As part of exploratory data analysis, we have merged all the data which we have received from the data collection team. And we have done the analysis on the data. Next slide, please. Yeah, so we have for social media addiction, we have approximately like 349 records, and for social isolation, we have 187, and for cyberbullying, we have 168 records. So yeah, for on this, we have cleaned the prompts and generated the word cloud for this. Next slide, please. Next slide.
Okay.
Yeah. So based on this word clouds, we can improve the prompting to the LLMs to generate better prompts, and we can give the better prompts to the LLMs to generate the better responses. Yeah, that's it. And we will be formatting the data for the model building team as well, so that they can train for on DPO. Yeah, thank you.
Thanks,
Thank you
Priyanka.
for your talk. Rana, are you here?
Hey, hi. Yes, I'm here. Can you able to hear me?
Yeah.
Yes.
All right, team. So after data collection and data preprocessing, we come to the model building part. So generally, our goal is to develop the preferable model to develop the QA chatbot for this demo purpose. So right now, what we have is we have FITO model developed by the Microsoft, which is already pre-trained for the specific task, so that we can use it for further purpose as well as right now. So and also we have other option as well for updated it on a large scale. Now we have already successfully, run it on a local system, generate favorable responses from the model for the specific purpose, which is mental health purpose. And also we are for next purpose, we are going to do DPU approaches, DPU implementation for fine tuning the model for for large scale purposes. Next slide, please. Great. So that's the model we are actually using. We can go ahead with the FITO model. So it's a transformer-based model which has 2.7 billion parameters. It was trained using the same data source as 1.5 model before, and augmented with a new data source that consists various NLP synthetic text. And it is also filtered from the website as well for safety purposes. So when access is against benchmarking test, Phi2 has showcased nearly a state-of-art performance among other models, which has less than 13 billion parameters. Come to the next slide. Cool. So what we have done is we have go through the Phi2 model, and successfully after implemented it on our local system, we got prompt like we have trained it like this way. We have give a prompt then as I want you to act as a normal mental health advisor. Use your knowledge of CBT, meditation, and other therapeutic practices to create strategies to deal with mental health issues specific to the user's query. And then we can use the user's query over here. And the prompt here is, and as the question is, it is so easy to chat with on phone and so frustrating to talk with people to their face. Is it normal? As you can see, the answer I have already make the response over here. I understand how frustrating you can talk to, can be talked to people on their face. So you can see it is giving us a descriptive answer for the specific prompt. Can you go to the next slide? Here is another prompt. If my post gets less like an interaction, I feel guilty and less confident about my personality. Is it a problem? As you can see, it is giving us a strategic answer rather than a descriptive answer. So it actually achieve what we need for the model building purposes. it gives us the professional like medical health chatbot. Cool. So can we go to the next slide?
Sure.
So after that one, what choice extra do we have, or and what updates do we need to present in the next meeting, or what else we will go through next? So we have two preferences right now, Mistral 7B and Llama 2. If we don't have any, like right now, we are also gonna do the DQ approach with these two models on a large scale basis after collecting the data from data processing team. Great. So I think next slide will be presented by our Streamlit team.
Thanks, Rana.
Yeah, thank you so much, guys.
So am I audible?
Yeah,
Yes,
Firoza.
Afroza.
Yeah, okay. So now I want to talk about the application design part of our project. So we actually integrated our Phi 2 LLM with a Streamlit application, which is like a chatbot. And as you have seen from the previous slides, how the responses are generated based on the certain prompts and all the engineering. So actually our we use inference from Hugging Face, but we use the free tier one, which is giving memory exceeding error to and to overcome that we are trying to integrate the Streamlit app with Google Cloud Platform, but we are currently facing some resource related issues and storage problem, which I am looking into it, and I am hoping that I will be able to show the desired output in the next meeting. So this was our update about the Streamlit application that we developed.
Thanks, Afroza.
Yeah. Okay. So there is the architecture from our overall project. For example, we have the Streamlit app. User will give us the question and answers. We will have the questions and user have to provide the answers. On the basis of those answers, we will evaluate through the LLM model, and LLM model, that will be a DPO training model, and that model will give us the generated response. Now, what is LLM DPO model training architecture? Move to the next slide. Okay, this is the DPO architecture design. For example, we have the massive data that is pre-training on base LLM. Base LLM could be anyone, like Phi 2, Mental Llama, or Detox LM. It can be any base LLM, and then we will move forward for the fine tuning. Here we are doing fine tuning on the basis of those base LLM models, and on this step we will provide the specific data set that actually data processing and data collection team is building right now. Okay, because I said that data collection team is actually building the data set on the basis of accepted or rejected, chosen accepted or chosen rejected. So we have two prompts, that is chosen I prompt and the rejected. So we will provide the prompt chosen to the fine tuning LLM, and also provide the prompt rejected. First, we provide the fine tuned LLM model the data, and that fine tuned model will give us the all the like chosen score and rejected score. Then we have the second one, that is frozen LLM with the same architecture like the mental llama and detox LLM, and that point we will provide the prompt rejected. Fine tune, we have only a prompt plus chosen data, and on the frozen LLM we have both, like prompt plus chosen and prompt plus rejected. And then frozen LLM will provide us the chosen score and rejected score, and that on the basis of those score we have loss calculation, and loss calculation will direct move towards the fine tune. So basically we have the backend. The model we are actually using is the fine tune LLM model, but the DPU is the on the back is running is like this architecture. Okay. So our background model is fine-tuned LLM model. Okay, then we have the next move. Okay, we are actually facing some challenges here, like GPU challenge here, and similarly we have less amount of data right now. We are collecting the data as much as we can, and third is we are actually having the issue with the stream data, because we need to connect the stream data with the model. So we have that issue also. So in next week we will move we will done these steps to done our work, like gather the data and work on the GPU training, because right now we are actually working on the 5 to model, but then we will move towards the GPU training model. And then we will actually work on the application development side, because we don't have app right now ready. So we will work on that also and focus on the deployment. Actually, first we did deployment today on the GCP, but we have some error here, so we cannot show it right now. Okay, so that's it for our next move. Okay, these are the active members that are actually working and providing their time to us, and they are like main, I can say, main bridge or pillars to our team. So yeah, thank you so much, all the team members written here. Thank you. Okay, so any question here?
Okay, yes, thank you, Aksa and Tracy team.
Thank
So
you.
then we can move forward with the team 3 presentation.
Hi everyone, just to say that previous presentation was great. I thoroughly enjoyed it. So thank you very much for that. First to say that thank you, Yaya. This morning I have sent you a message regarding update from our team. We currently do not have a code to present, as our team is currently working on the model building So I do not have I haven't collected notebooks from them. However, I have received feedbacks, which I'll walk you through in a minute. Update from last week, we were going to go with our model building, which was going to be the implementing of RAG calls, along with the LLM models as well, which is going to work on the base of retrieval and generator. However, we also decided to add a second approach, which is more experimental, but we believe it's going to perform, produce good results. And currently, our colleague Jalen is working on this as well. This second approach is going to be using reinforcement learning with Q-learning as well, for which she is going to walk you through in a minute as well. So I'm just going to quickly share my screen here. Okay. Right, so first we're going to start here. This is our this is our model building team now. We have an update. Our lead is now Abibi, since Sai stepped out of the project last week, and our co-leads are now Araf and Jadin, which they've been doing a great job in order to push our project into a completion now. So this is our architecture currently, which hasn't been changed, except we added a little bit of a change here in terms of the vector storage and the reinforcement learning as well. So this is the only difference here that we haven't. Like we said, this is still working on the base of retrieval and generator, our RAG approach with LLMs. So, and also what we also working on is the moment sentiment analysis, which they're going to be for the purposes to create history of a user's mood. This, for example, if the mood increases or decreases based on the interaction with the chat, we're using sentiment analysis in order to determine this. Jadin, she had results using a XGBoost classification model using bird-based tokenizer, and this she's done that in purpose of detecting mental health conditions. The scores that we achieved, she achieved, excuse me for this, is an overall performance of 71%, which we decided to try another model for that. Maybe we'll get a better score for this. I have decided to go with the naive-based approach, as I've worked previously with this and produced really good results. I will try this tonight and see if I'm going to get better accuracy for this as well. So this is our architecture as well. Like I said, it works on the base of retrieval and generate. And this is our reinforcement learning and Q-learning. I'm going to pass this over to Jadin, which she would walk you through in depth on how this is going to work exactly. Jadin, you can hop in a call if you're here, of course.
Sure. Thanks, Yanni. So I'm going to present about using the reinforcement learning, using Q-learning for this chatbot. So I would say that this is a bit different approach than what everyone else is doing. We are not So this one is actually, in the promises of when you're approaching to a chatbot, when you have issues, you have a certain preference. Maybe it depends on the time of when you are and where you are, or how you feel right now. You might want some more encouragement, where you might want more empathy, or you might want to see if we can get some medical help, right? So I would just think that this preferences changes depends on the person and also when this person is asking the question. So our reinforcement learning model is adapting to provide the right type of personal touch to what kind of AI tone we are going to provide in terms of this encouragement, empathy, and suggesting medical help type of thing. And then there's another side of things that is selecting the right questions. So we will be starting with detecting users' sentiment and also their mood. So the mood will be, do they feel positive, negative, or neutral? And their kind of mental health condition will be detecting would be, do they have some sort of sign of ADHD or anxiety or depression? So based on that, we'll choose, okay, if you look like you have a depression, then we will ask the questions related to detecting this depression related questions. So we have a pool of questionnaires that's related to depression, anxiety, and ADHD. So in the end of this, our chatbot reinforcement learning model, we will have chosen one, the AI tone, and the two is of which type of question. Then we can pass this result into the LLM. Hey, this is the condition. Can you generate a response according to this? Then it will generate the natural response and the chatbot will deliver that to the user. So by having multiple chats through this chatbot, this Q learning table, a Q table will be updated to see, okay, this user prefers more of encouragement. This user prefers more of empathy and things like that. And that will be the cycle of the chatbot. And it will end when the user says goodbye, then that'll be the end of the chat.
Okay, so let me know, Jadine, if you're finished.
Yeah, I'm finished.
Yeah. Okay, great. So something else I wanted to present here. Actually, our colleague Abibi, just about 20 minutes before this call, he updated me as well. Unfortunately, he's experiencing a health issue right now. But he sent me his update as well, which is a demo of a chatbot on how it looks with our RAG approach and LLM as well, which looks like it's almost completed. However, he asked me to present it here in the meeting, which I'm going to be doing now. So like you see, it's the design is still not completed, so bear with us until the end of the week. We'll be having this. So obviously we have an input and response. Currently, he's asking the chatbot a question here.
Yanni, are you sharing the other screen?
Oh, sorry about this. I'll just start sharing again. That might help here. Okay, apologies about that. Right, can everybody see the screen here? Jaren, can you give me an update, please?
Not yet.
I'm not sure. I'm literally presenting this from the Slack. Would you like to try and share your screen? I have no idea what's happening here. I wouldn't want to waste time here from the call. Jaren, do you mind doing this?
Just 1 second. Let me try. Okay, let me try sharing. Do you see the screen?
Yes, there you go.
Yes.
Okay.
Yes, Jane.
Great.
Okay, let me play it. I will let you speak over it.
Yes, great. So currently, like I said, our design is not completed. So bear with us until the end of the week. We'll have that. Like, see, we have an input, and obviously our chat is generating a response along with the chat history as well. which that would not be there, but I will refine this. So also we have an input, which is a question, and our chatbot is going to be generating a response as well. So like see our user is asking how often anxious and left out, see my friends on social media, how to deal with FOMO, and our response is going with explaining what the FOMO is and how they can manage their symptoms as well. But what we're really trying to avoid is obviously using any sort of like giving any sort of symptoms or diagnosis here. It's just purely about management. The chat history is still being displayed there, so we'll remove this as well. I think it's a great, it is a great input that I've received from a baby as well. I'll hear a bit more from here later and I'll update. I'm also working on documentation, which I currently almost have it ready, and I'll put it in Notion for you, Yaya, to see. And sentiment analysis will be ready by tomorrow morning. So this is on our end. Thank you, Jalen, for presenting this. Open for any questions here that you maybe have. I think maybe no question is a good sign. Hi, Basan.
Yes. Okay. Okay. Yeah. So you can just keep it short, Basan. Okay. Yes.
Yeah. For the reinforcement learning, I would like to know how you guys are collecting feedback back from the user and how you guys are using it to create the outcome of the model. Like I did not see in the picture, there is a feedback from the user. There has to be some loop, I believe.
Yes, Basant. So our way of collecting the feedback is implicit for now, and that is by detecting the user's mood from the chat. So each chat user's text, we will detect it if the person feels positive, negative, or neutral, and we will collect the history of the change of the mood. So if my response from AI is providing the user mood increase, then okay, so this is the feedback and we give 1 reward. So if it's decreasing, and we give -1 reward. So that's how we update the Q table.
And this is based on the way how our user is interacting with the chat as well. And this is the purpose of using the sentiment analysis here.
Yeah.
Like Jadin just mentioned. Thank you, Jadin.
Okay. Yes.
Yeah,
Thank you, team
also,
4. Yes, team 3.
Just a minute.
Okay.
One more. Okay. In the chat, I have said that when somebody asks the question, it gives a list of answers and what to do and how to do. Is it not similar to what the Google search can give it? How a chatbot and a Google search has to be means. What I need to say is that the chatbot should be more short because it doesn't have to like a search do all the details. Yeah, that's what I want to differentiate. Is it not to like see in a Google search you get a good number of results, and what you guys done is combine them and summarize them. Chatbot is something different, right? It's semi-human. Yeah. So I think you should focus on to that side more than just giving the feedback and other things. That's what my feeling is. Yeah.
Yes, tomorrow we'll be having a meeting with the team to discuss that as well. I think some sort of fine tuning would really help with this in order to achieve better responses as well. So it does not look like you say, like it's been a Google search, for an example. This is just our initial demo, the first one that we produced today.
Okay. Okay. Thank you.
Yes. Thank you, team 3. That's a great presentation. Okay. So every team has their unique ideas and the model they build, right? So it's different. So now we can come to the team 2. Yes, team 2, Narayan, you can start the presentation.
Hi. Yeah, just a second. I'm going to share my screen. Hope my screen is visible to you. Okay, so here is the status we have so far uh, for week 3, right? Like so far we have completed data collection and data pre-processing. So under data collection, we have collected data from Twitter, data which has 900 MB data size and 190,000 records. And another source is from GitHub, which has uh, Facebook data, which is related mostly on depression and anxiety. That part is completed. And coming to data pre-processing, last week we have done initial processing, pre-processing on some EDA. Let me show you that. Like from the EDA, we have some. Uh, we have come up with this analysis saying that these are the some kind of top 10 words which are highlighted. I mean, frequency is more, especially sadness is more, like more than around 70,000 records has this, something like that. And coming to this, so there is some more. I did not add a few more uh, uh, EDAs here. So this is word cloud we have generated from that EDA. And from the word cloud, again, we can see that mental health, sadness, and a few words are more frequent in our data set. So coming back to the presentation here, right? Like currently we are working on model building. So we had a meeting last week, and we are still in process of going with the initial steps with the model building. Our team, most of the team members, right, like pretty new to this one. So we are still exploring this right now. So hopefully, like this week, like 1 or 2 days, I think will come up with some uh, 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 initial architecture for what we are going to use, which models we are going to use. Uh, so that is the thing. And so so for whatever we have completed, we have kept everything under a DAX Hub repo. Um, so this is, I just wanted to share. Oh, sorry. So as we discussed earlier, we have a separate branch. So we have this uh, a folder structure created. Pre-processing, we have kept everything ready. Like if you go back, let's see, let me show you this, whatever the pre-processed data. So yeah, so for whatever we have done pre-processing, we have kept under this folder, which is like pre-processed data. So from this, we are going to proceed further for model building and rest of the steps. So there is much to talk about it. Yeah, this is any questions on this one so far? And this is the architecture. We are going to improve this architecture still. This is the basic architecture we came up last time.
Okay, so are you completed the presentation, Naren?
Yeah, yes, yeah.
Okay, okay. We hope you will be having more work to show up for the next meeting, hopefully.
Yeah, that's the plan actually. Like we have listed out who are uh, active participants, and we are maintaining separately in the team list here. It is which is shared with everyone. So yeah.
Okay, okay, sure. So we can now go ahead with the team one presentation.
Yeah, so sure.
Yes, team 1 lead.
Yeah.
Narayan.
Hey everyone. Shantanu won't be joining today, so me and my teammate Vishnu will share updates of the week. Just a second.
Yeah. As Ganesh. Yeah. Sorry.
As Ganesh, yeah.
As Ganesh. Okay, sure.
Okay, so this week we've mostly made progress on data pre-processing pipeline and model architecture. Data pre-processing pipeline includes like Python scripts to apply text cleaning and pre-processing, handling emojis, converting numbers to text, applying some extra cleaning like removing tags, punctuation, URL, etc. Also dealing with stop words and stemming and lemmatizing and bringing the words into the root form. So we have all the functions and scripts and have applied them to a limited collected data on Reddit on only anxiety tag. But we have it ready to apply to additional script data we will have. It's continuous and it's in progress. Also, we've applied text vectorization using TF-IDF method and made some progress on topic modeling and semantic analysis. These tasks are still in progress and we need to update them with additional script data. But yeah, we have made some progress on them and probably will be ready to share more results in the upcoming week. I've added some team members who were actively collaborating on a data pre-processing step, and my teammate Vishnu will continue on talking about model architecture and model building subtask update. Vishnu?
Yeah, thank you, Ganesh. So do you mind if I take over now?
Yeah.
Okay, if you don't mind, I would like to present from my screen, please, just because I'm more comfortable there.
Okay,
I have a few.
I'm stopping.
Okay, sure. Sure. Okay, can you guys see my screen?
Yes, Vishnu, we can see the screen, but you are not sharing the presentation yet.
Yeah,
Okay.
Is the presentation visible now?
Yes.
Okay, then, so yeah. So thank you, Ganesh, for giving you a synopsis about the current data pre-processing. Okay, so now my name is Vishnu, guys, and I am the current lead for model building in Team 1. So 1 week back, me and my co-lead Anish have decided on this particular architecture over here. This is more of a rough view of the entire architecture. So let me zoom in here a little quick. Okay, I'm going to zoom out of it, sorry. Okay, so this is our architecture plan actually. First, we obviously have the user interacting with our UI, giving it input text and output prompts. So what we decided is to employ an authentication service or an authentication program that's gonna authenticate a user's Reddit credentials. Our initial plan over here was to make sure to scrape Reddit data from a user's Reddit history by initially authenticating to it first. So once we authenticate it, the data is scraped and it is further used for performing model building. Sorry, not model building, sentimental analysis, as it is shown over here. We will perform sentimental analysis by scraping data which is around 3 to 6 months. We've taken a limit of about scraping data to 3 to 6 months due to resource resource storage and allegation limitations. So once a user has been successfully authenticated, if he's failed to get authenticated, then it will send an error prompt back. But if he is successfully authenticated, then yes, the data is scraped and sentimental analysis and topic modeling is performed immediately on the initial scrape data. We are actually dividing this entire process of this entire chatbot into 2 main steps. The first step, which is going to take around 5 minutes of processing time, like that is what we are assuming, because initially we are spending 5 minutes to scrape the data, perform sentiment analysis, topic modeling, and create vector embeddings to create your initial foundational database. Once topic modeling and sentiment analysis is done, when the system has identified necessary emotions, the post and comments are both either combined, combined pre-processing or individual pre-processing based on what the data pre-processing team has been performing. Depending on that, we are converting all of them to vector embeddings and are putting it in the vector database. So that is the first step. And this is basically a summary of the first step. Scraping the data, performing sentimental topic analysis, performing posts, and we're going to be uploading it in ChromaDB. That is the vector DB we have chosen for this project, ChromaDB. And immediately after the scraping is done, after the scraped analysis data is done, the vector DB actually obviously contains pre-processed data from the data pre-processing team, which has already been kept. So it's going to perform a similarity check or a similarity function between both of these data, and text embeddings will be inputted inside the vector DB. Then we have the second step over here, which is the initial prompt from the user. Oh, sorry about that. The user will send an initial prompt, which is going to be converted into text embeddings using a Python function. And that is then sent to vector DB to perform his initial query. When the initial query is performed, the vector DB is going to create an input of data, and it's going to be inserted inside a prompt template, which the code is designed by the prompt engineering team in the model building team, prompt engineering task team. That prompt engineer template is going to be sent to our is going to be sent to the LLM. We are choosing Llama, BERT, or Bloom, but we are building our code usually based on Llama, so we're going to choose Llama for now. And so when the prompt template is kept inside Llama, it is then going to provide with a fetched response that's going to be visible to the UI and visible to the user. So this is the architecture that the Team 1 model building has decided. This is a more summarized version of our architecture. We pre-processed data submitting embeddings to the vector DB. We have the initiation of scrap and analysis, performing embeddings into vector DB again, and finally initiating a prompt engineering step. Vector DB is going to provide a template, and vector DB is going to provide embeddings to the prompt engineering code. Prompt engineering is going to provide the template to the LLM, which is going to provide the output response. And this is the overall architecture. These were the initial list of LLMs that we've initially decided. But out of these, I think what we are going to go with is either Llama, Bloom, or BERT. All of them arranged in the order of votes, where Llama received the most number of votes for being implemented. So 70% we're going to be using Llama for the final data. For the final model. My co-lead and my co-lead Anish have already worked or have started working on the LLM-based model. We are not going to fine-tune the model. We are going to be depending on RAG for performing the prompt templating and for providing embeddings from external data, or in this case, pre-processed data. So it's around 50 to 60% complete. And unfortunately, my co-lead Anish is not available right now because he's busy with a good number of interviews being lined up this week. He's going to be available Wednesday onwards. So currently the code is with him. I don't have the current access to the code. I have contributed a good amount, but overall now, yeah, these are the code submissions that we have received from our team. This is overall the authentication code that we'll be using for authenticating a user. We have defined a under fetch user history function where we are going to be fetching a user's history. First, we are using a sub-function of authentication where we are using Reddit prompt to extract this data. To extract whatever data, this client ID and client secret is connected. These variables are connected to a UI. Unfortunately, the UI is not ready yet, so it may seem a bit confusing when you're using it. So yeah. And if it's not going to get authenticated, it's going to print authentication failed and it's returned to the user. Or else, this is the schema that we have provided with title, ID, author, URL, score, etc. All data in this particular schema is going to be sent to the sentimental analysis code. Or else it's going to just print no history found. So the sentimental analysis code, we are using sentimental intensity analyzer and polarity scores to check the score of the overall sentiment, whether it's positive, negative, or neutral. We're going to be adding more emotions sooner, but this we have created just as a trial run. And this is the main response code of how the template is going to give back a response to the user by the LLM. It's going to be first, eventually in the get response code, we are receiving a message. GPT-4 is just temporary, guys. We just temporarily tested with GPT-4. And these are the error messages. It's going to give us a confidence score. If the confidence score is lower than the threshold, then it's going to give out a low confidence score and it's not going to continue fetching the response. And this response code is eventually connected to the user request. Yes, so it's still a work in progress, guys. We'll be done by Wednesday, since a lot of people in team 1 are not experienced. This is their first time participating in an LLM based project, or even knowing the topics in LLM itself. So after all of that now, so yeah, we're going to integrate all of these codes into the final code and then send it. And then integrate it into a full application, which is sent to our main code. Yeah, that is so far the progress from team 1. Any questions?
Yes, thank you, Vishnu, for your presentation.
Yeah.
So we expect all the teams completing and having a demo by next week, the coming weekly meeting. Yes, any open questions right now? Also, I want to add here, so in terms of us, so this project is last project with Omdena. So we are all launching our own projects, and we have our own portfolio with our startup, so which is Optimum AI. And we are launching a new project by next month, which is AI Planner with multi-agent architecture, similar to Rabbit R1 or any other companies. They are building different chatbots for multiple custom planners. So yeah, so that's why by end of this week you need to complete the project, and also similarly open call AI. So we are trying to build that kind of use case with our startup. We'll be having different projects set up, so you can also be part of our ongoing projects from next month. So hopefully active collaborators will get certificates from Omdena by at least by end of this month. So I expect you to actively collaborate so that I cannot guarantee any certificate after 25th of March. I hope is that clear.
Just to ask quickly, yeah. So we should have the completed demo by next Monday. This is my understanding. And also I remember there was somewhere it was mentioned that we would also need to write a report about our project. Is that correct as well?
Yes. So but we have a project completion and handover date with Omdena is 25. So I won't be active with Omdeno after by end of this month. So I may not give you certificate. If you come back to me, I'm part of this project I want some more time to complete the chatbot, right? I cannot give any more time.
No, that's sure. Could you please just quickly give us some advice in what sort of format should the report look like exactly for our
Okay,
project?
just a minute. Yeah, so just a minute, I will share the screen.
Great, thank you. I'm sure that'll be very helpful for the teams as well in case they're wondering.
The screen visible, right?
Yes, yeah, thank you. Just maybe an example how a report from Dana should look like.
Okay, sure. Just a minute, I'm checking again. Okay.
Thank you. Yeah. If this is if it's difficult for you to find one or anything like that, we can always post it in a Slack. That's perfectly fine as well.
Okay, no problem. I will share the relevant document, okay, format into the Slack channel. So in the project leads channel, you can go through it.
Yeah, thank you very much. Appreciate that. Cheers.
Yeah, any more questions?
Yeah, one question for the next week's demos, given that there will be the final kind of demo, right? Final action. Anything that you would not call out from your expectations perspective, if demo should include these basic minimum things, just to, I mean, I wouldn't say minimum things. What is the success criteria that you would look at?
So you should able to present the demo using a UI chatbot. So you're able to access it. You're able to demonstrate in real time and give some kind of output for your questions. So that is
okay.
Yes, and possibilities of extension of this project with us will be depends on active collaboration, innovation, and how you will be managing this project. So if possible, we can try to build a prototype product so that can be launched in real world to get the product live for different users, and if possible, the monetizing the product as a startup product.
Okay.
So
That's
any
a
more
great
questions?
question. Thank you. No, I'm just saying it was a great question that actually I wanted to ask something like this, but he put it greatly into words. Thanks.
Yes, Basant, do you want to add anything here?
Yeah,
Final conclusion?
everybody has done a great work. Yeah, congratulations to all the team and those who have not done the modeling part of that part. I urge them to start doing it because RAG is going to be industry standard and it's pretty much a common skill most of the LLM users will have. So it's better to learn it during this time, and it's a good opportunity. And also the teams which are really doing good in terms of thinking in innovative ways, I want them to really understand what is the underlying problem and how to solve them and what are the ways to solve them. Because if you present this work anywhere in interview or any places, people will not be interested to know whether you have solved a problem or not. They want to know what are the limitations, how did you solve it, and what are the ways to solve it. So it's really important to learn all those things, and this is a good opportunity for it. It's a real live practical example which you guys have in hand, and a lot of learning can come out of it. And that's all from my side. Thank you all for your work.
Yes, before final conclusion, I'm just dropping here our project website link to join our ongoing project with the. So click on this optimumai.in and go through the website. So into community, we have 2 projects started. So we will start with first AI financial planner with multi-agent architecture similar to Rabbit AI and Open LLC AI and similar to Jarvis, right? So we try to eliminate humans to does not use apps on mobile, so which we usually use manually. So you go through your mobile app and try to book your tickets, book your hotel, or book anything like cab. So with prompts, with just asking some kind of plan, creating plan and all, so it lay out a plan with a prompt and also able to schedule, book flight, book everything, right? So we try to eliminate all these things, and also mostly we're looking into financial management related aspects of everything, and then the next part will be coding and eliminating the coders, software developers and all. So making the code base to be completely with build using agents and AI. So yeah, thank you all for joining the weekly meeting for our project mental health. Hopefully we'll be having concrete demos next week, and the final demos by 25th. We'll conclude the project on 25th, and that is the final schedule with you all will submitting has project report, demo, and required documents. That's it. Thank you all again. Have a great day. Bye.
Thank you. Yeah. Cheers. Bye.
Bye.